So in this video we discuss about the design code of full subtractor using half subtractor. So before going to see the Verilog code, so just look into the what is the full subtractor and how you can design by using full adder with half subtractors. You already know about full subtractor and half subtractor. In previous videos I already discussed about this full subtractor and half subtractors and the separate codes like that. But in this video I am going to discuss how to use half subtractor. From that half subtractor we have how to build the full subtractor. So let's see that there are the two half subtractors. In previous video how we learn about how to design a full adder using two half adders. Like that same here also full subtractor using half subtractor. In that video we discuss about we take two half adders and then we can connect those wires by using wire data type. Like that same here also by using two half subtractors we are going to design the full subtractor. So the block diagram and our schematic diagram it looks like this. So we all know that half adder consists of half subtractor consists of XOR gate and AND gate. So only the difference between add and subtractor is about NOT gate. So one of the input is NOT gate, that will be the difference between the adder and subtractor. So now see, in full subtractor there are the three inputs. We are nothing but consider this as A, B, C are our inputs like that. So here in this diagram they say like B in is the third input. So if you feel something clumsy you can take it as a B, C input. So A, B, C are the our inputs of the full subtractor. So full subtractor two inputs will connected to half subtractor inputs, means nothing but XOR gate two inputs and AND gate two inputs. But the carry should be, means here in subtractor we say that there is borrow, so that's why you denote with B and the D is the difference. So why you are going to subtract the two bits at any 4 or more than 1 bit, so we are going to the while you are doing subtraction we say that it is a difference. So while you generating carry it is called by borrow. So like that, so in generating the borrow we use NOT gate for the second input like that. So now what we are going to do, the first half subtractor of XOR gate output will connected to the input of second half subtractor XOR gate. So it is our second half subtractor XOR gate. So these output whatever the XOR gate sum is connected to the XOR gate of second half subtractor. So these output will goes to the input of second half subtractor XOR gate. So another input is nothing but our C, third input of the full subtractor will going to be input of the second half subtractor. So now by these output and input is connected by a wide data type. You can take any variable W1, W2, W3 like that. So you can use any wide, you can use any variable and define it as a wide. So you can connect the input and output ports like that. We use simply wide data type. You know register is for storing the values, wire is for just transfer the data from one point to another point or one port to another port like this. So that's why it simply pass this first input XOR gate output is going to be input to the second half subtractor XOR gate input. So that's why we simply use wide data type and declare a one variable here. So next what we are going to do, so again these W1 wire is going to be assigned to the carry also. So what are the two inputs going to the XOR gate, that those inputs are going to borrow, means AND gate also, but the only difference is the NOT gate of this second input is going to the AND gate. So by that we get the difference of the full subtractor and the borrow. So how you get borrow, direct full subtractor borrow, how you get, not directly we get whatever in yesterday say whatever the carries of the two half adders will going to be OR operation like that. Here also same, the borrow of first half subtractor and the borrow of second half subtractor are going to be OR operated, then we get the borrow of the final full subtractor borrow. So like that we get the difference and borrow. Just look into this block diagram, it's by using this block diagram only you are going to write a code. So now what we have to going to do means, so first we have to write half subtractor code. So by using this half subtractor code we are going to design the full subtractor. So how you write means, so starting we start with module and end with end module here. So we have to write the module name. So half subtractor is our module name. What are the inputs here, half subtractor? So I simply draw the block diagram here. So half subtractor AB are the inputs and difference and the borrow or carry is whatever the, you can represent it by borrow. So borrow. So difference and borrow is our outputs. So now we are going to do, so the inputs are represented with the input keyword, means they are the input ports. What are our input ports? A comma B are input ports. So what are the output ports of our half subtractor? Difference and borrow are the outputs of the half subtractor. So you know the formula of difference and the borrow. We already discussed in previous videos. If you don't watch, go through that, then it is easy to understand. So the formula of the difference is nothing but A XOR B. So in Verilog we represent XOR by with cap symbol. So SN borrow is equal to, so you already see that the borrow AND gate is nothing but one input is directly given, another input is inversion. So that's why you simply use inversion of A and operated with B. So one of the input is not gate means inverted and another is the original one. So like that we assign the borrow by using this assign keyword. While writing this assign, it is nothing but a data flow modeling style. So the modeling style also we are discussed. If you don't watch it, so go through that. Then it is easy to understand which type of styling, which type of modeling we are using. So I can't mention every time this is this type of modeling style like that. So you have to understand. If you don't know about the modeling style, just go through that video. So here this is the difference and the borrow. Like that, by using this operation we have to use the assign keyword and assign the RHS value to the LHS side. So this is our half subtractor code. By using this half subtractor code, we are going to design the full subtractor. So how are you going to design? So start with module and end with end module here. So again we have to write another module name for full subtractor what you want. So I simply write module full underscore subtractor underscore half like that. So for full subtractor, what are the inputs? So we already know the block diagram means it is a full subtractor. They are the three inputs for the full subtractor, ABC, and the difference and the borrow. So two outputs, three inputs. So we can represent the input with input keyword means input ports ABC and output port difference comma borrow. So why I write wire means I already discussed in previous video. Now also I am going to say wire. Here we can see, observe that. So if you want to connect any output port to other input port or other input port to output port without any storing of values, then you simply declare it as some variable and make it as a wire data type. So here we can observe there is a wire which is connected the output port to the input port. It just carry the data of output of the first XOR gate going to the input to the second XOR gate. So that's why I simply represent =1 as a wire. So now see half subtractor. It is our module name means you have to instance this half subtractor in this full subtractor. So that's why you write the module name of the half subtractor what you represented here. So you simply write this half subtractor module name here and you have to make any instance name. So you can use any name, your name and anything what you want. So no need to particular specific like that. So we are going to assign the means connect the ports means here see what are the inputs of the half subtractor. A fine let's see. So this is our half subtractor AB and the difference and the borrow. So now what you are going to do? So they are the three inputs in the full subtractor. Let us assume they are the full subtractor inputs. So what you are going to do? The full subtractor A is connected to half subtractor and B is connected to the half subtractor. So that's why you connect A and B. So here in the block diagram we observe that. So A and B means they are the three inputs for full subtractor here, but we are going to only assign A and B to the half subtractor. So that's why simply write A comma means A means one input of full subtractor is connected to one input of the full half subtractor. So here also B is nothing but here we can observe. So here B is the full subtractor input which are going to assign it to the half subtractor another input. So half subtractor has two inputs. So full subtractor has three inputs. So now what you are going to do? You have to connect these three ports with these two ports. So how we are going to connect? So we have to give three of them two means there are three, but in those three we are going to assign two inputs to the half subtractor. So that's why I write A comma B. And next what are the outputs? It is not our final output. So whatever coming from this and this AND gate, so it is our not final output. So that's why you are simply make it as wire. So for making wire we represent the variables as =1 comma =2. So that's why we represented wire data type =1 comma =2. So you can write like this. So half subtractor. So again there is another half subtractor in the block diagram. This is half subtractor 1. This is half subtractor 2. So what is the half subtractor 2 inputs and outputs? So one of the output of the half subtractor is going to the input to the second half subtractor. So =1. So whatever here you can observe. So this output is going to connect to this input. So that's why simply write =1 as the input to the second one. So again C. So now what you are going to do? So another input is nothing but our C. So that's why simply write C. So what you get the output? So difference you get, and another thing is some value, but it is not our final value. So that's why again you make it as a some wide data type. So now how you get final borrow means, here you can observe the borrow of first AND gate and second AND gate, means first half subtractor and um first half subtractor and second half subtractor outputs of borrow will going to be OR operator. So that's why what is the borrows here, double G2 and double G3 are borrows. So simply OR operate here by using this. OR operation is nothing but is like single line. By using this operation we are going to assign the borrow value to borrow keyword. So end with end module. It is our design code. Up to now, if you have any doubts you can comment it. So next it is our test bench code. Test bench code I already discussed in the previous video, that is full subtractor video. So the module names only be going to change, so nothing will change here. So if you have any doubts about this test bench you can comment it. I will explain in detail about this test bench also. So I think no need of this because I already discussed in the previous half full subtractor code itself. So I already done the full subtractor video. I already post it. But if you don't watch it means you can check it in my description. I will give the link of the full subtractor too. So in that video there is a test bench design code. So it is similar, same, both are same, but the module names here full subtractor half or full subtractor half underscore TB. These maybe these two names will be going to change. Otherwise all are will be same. So it is our output waveform while you are going to run. So see how you are going to means by using this line we can represent these values here. So here you can see A is equal to 1 and B is equal to 1 and C is equal to 1. So we know the formulas of difference, and now we know the formulas for borrow or carry. So you know the formula for carry or borrow also. So by using these two formulas we are going to find out these two, then we get this difference and borrow. Sorry, this is the borrow. So we get the borrow and difference. So by doing those operations by using the formulas, then you are going to understand whether your input is output or getting is correct or wrong. I already discussed how you get this waveform on all the full subtractor video. The only difference is our design code. Here you are particularly why I am making this video is nothing but how you design full subtractor using half subtractor. Remaining test bench code and output waveforms are similar to the full subtractor code itself. The only difference is our design code. When in the market when the full subtractors are not available, by using the half subtractor, the half subtractor is available. By using half subtractors you are going to design the full subtractor. So that's why the design code is the main topic in this video. So if you have any doubts about test bench code and how you get waveforms, just go through the full subtractor video. That complete detail and explanation in the full subtractor is going to there. So until then, thank you. If you have any doubts you can comment it, and thanks for watching. Till then, bye.